And I just wanted to show you where we are. No, this is not what I'm looking for. This is what I'm looking for. Okay, so let's see what is left. So we are in the middle of 4.2. Hopefully we're going to, say it again. Yes, I am. Yes. Thank you. So we're in the middle of 4.2, and we're trying to accomplish these two, or as much as we can. And then we have 4.5, 5.1, 6.1, 5.4, 5.5, and 8.1 left. So we'll see if this happens, maybe sooner, maybe later. I don't know. This is a tentative date for us for test 3, but we'll see. It could be sooner, so we can start reviewing for the final exam. Yes, Krista?
There's not a specific date for the closing, right?
No, but I would like you to work on them so you can get the credit for that. Yes. So as soon as possible. Okay, any questions? Okay, so let's go back. Let's say 4.2 on page 490. Let's say problem 78. We're given a function f of x equals log. I don't see the base. What is the base when there isn't one? Very good. Awesome. Thank you. Well done. Very good. The question is asking us the same thing. Find a domain. What do I have to write? The base is 10. We don't write it. It's by convention. LOG means base 10. We're not solving. I have to write something to solve. Yes? Yes? Careful. Excellent. That's the condition. Very similar to the square root, but in this case, not 0. So then I move 7 to the other side, negative x greater than negative 7. What happens next? Excellent. Very good. Awesome. So now the domain of this function is negative infinity to 7. Perfect. Okay, I would like us to look at a word problem. Page 491. We're given a function f of t, which is 88 minus 15 natural log t plus 1, where t is a number between 0 and 12. Let's read the problem. Students in a psychology class took a final examination as part of an examination, full stop, as part of an experiment to see how much of the course content they remembered over time. They took equivalent forms of the exam in monthly intervals thereafter. The average score for the group, f of t, average score, after t months, was modeled by the function f of t equals 88 minus 15 times natural log t plus 1. This is our function. It gives us, as a function of time, it gives us the average score. Okay. Part A. What was the average cost on the original exam? When we talk about original or initial, what do we mean by that? What are we trying to do? What are we trying to determine? This is not a linear function. Say it again.
Starting number.
Exactly, which means? Yes, of course. Always the initial or original or the starting point is always f of 0. Yes, thank you, Madison. Okay, so this is 88 minus 15 natural log of 0 plus 1. How much is 0 plus 1? Okay, we don't know what natural log 1 is. I have no idea. But I know that this can be changed into an exponential equation. What is the base here? Again, I don't see a base. Careful. These two cannot be the same. The log has a certain base that you already told me, 10.
Oh,
Exactly. Very good. So e
1.
raised to which power is 1? Counterclockwise.
Here.
E, exactly. E raised to which power is 1? And the answer must be 0. There is no other possibility. So then natural log 1 is 0. Since we are here, what about log base 5 of 5? What do you think that equals to? Exactly. What do you think log base 1/2 from 1/2 equals to? Exactly. 1/2 raised to the first power is 1/2. 5 raised to the first power is 5. So in conclusion, we didn't finish anything yet. But here in the conclusion, we say log in any base of the base is 1. Log in any base of the base is 1. Log in any base applied to the base is 1. Log of 1 here is 0. So log base 5 of 1 is 0. I jumped. I'm sorry. We didn't talk about this one. In my head, I was already at the second property. Sorry about that. So don't disregard this one for a moment. We haven't talked about it. So log in any base of 1 is 0. Log base 7 of 1 is 0. Natural log of 1 is 0. Common log of 1 is 0. So now since I mentioned this, let's talk about it. Sorry about that. In my mind, I was already on the second property. So log base 5 of 5. I have no idea what this is, but I know that I can change it into an exponential equation, starting from the base, counterclockwise, not times, but 5 raised to equals this. Yes. So the answer is 1. So we just studied two different properties. Log in any base of the base is 1. This is the general rule. Log base 5 of 5 is 1. Natural log of e is 1. Log of base 1/2 of 1/2 is 1. Log in any base of the base is 1. My apologies, this is not relevant here. It was on my mind and it came out. So, and I wrote it, so now I had to explain it. Okay, so coming back to our function to find f of 0, since this is 0, natural log 1 is 0, how much is 0 times 15? 0 times 15, 0. How much is 88 minus 0? 88. So the initial score of the exam was 88%. Well done. Part B. Any questions? Yes, let's go back. Yes.
I don't know where I got lost. I understood when we were getting the natural log 0.
Is it clear that this becomes 0 because it's natural log of 1? So f of 0 is what we are looking for.
Yeah.
And then 0 plus 1 is 1. But natural log 1 we just determined is 0. And 0 times 15 we just said it's 0. And 88 minus 0 is 88. Better?
Yeah.
Perfect. I confused you with all of a sudden I was
It
thinking.
was just, yeah.
I know.
It's fine.
Sorry about that. My fault. Sorry. Okay, part B. What was the average score after 2 months, 4 months, 6 months, 8 months, 10 months, 12 months? Okay. So we're going to create a table. I always tend to write X instead of T, but this is T. Okay, and f of T. 0, 2, 4, 6, 8, 10, and 12. We already have the first answer. So f of T in percent, 88 is the first answer. And we want to put this in the graphing calculator. in y equals, because I did this problem a couple of hours ago, my other class. So it's 88 minus 15 natural log of x plus 1. And then we go to second and table and plug in those numbers. When we plug in 0, we get 88. When we plug in 2, we get 72. I'm going to round it up. So 72, and then 64, and then 59, and then 55, and then 52, and then 50. Did we get the same numbers? Now, in part C, we're asked to graph this function. Is this okay?
Graph.
I'm sorry?
Graph. Or
No. Can we graph now?
yes.
Perfect. So let's graph. Part C. I see a t goes from 0 to 12, 2, 4, 6, 8, 10, 12. But f of t goes from 50 to 90. So I'm going to put a break in here and say this is 50, 60, 70, 80, and 90. And this is f of t in percent.
Wait, we need all 12? I thought we went to the. Oh, never mind. Different problem.
That's okay.
Different problem.
That's okay. So let's graph 0, 88, 2, 72, 4, 64, 6, 59, 8, 55, 10, 52, and then 50. So here's the graph. We cannot extend it because we don't know what happens outside of it, of course, and not a negative time anyway. So this is the graph. It's kind of depressing that in 12 months, right, from 88%, it drops to 50. Questions? Questions? Okay, so let's continue then with properties of log. Properties of log function. Only this function has these three properties. No other function has these three properties that I'm going to list in a minute. Also, there is what it's called the change of base formula. So 3 properties plus a change of base formula. Property number 1 is the product rule. Log in any base of a product. It can be 2 factors, 3 factors, any number of factors. This is the same with log base A of x plus log base A of y. Please do not confuse this with log x times log y. That's not what I'm talking about. This is log applied to a product, and the relationship goes back and forth. Meaning, if I'm given log applied to a product, I change it into a sum of logs. If I'm given a sum of logs, I can change it into a log applied to a product. So it's not just one way, it's both ways. Okay, as an example, common log of 2x is the same with log 2 plus log x. That's all it means. Because 2 times x, it's a product, 2x is a product. Then I can apply the product rule and write log of 2 plus log of x. The next property, the second one, is the quotient rule. Exactly. So it will be log in any base, but this time applied to a ratio. And yes, it will be the difference. Same base, of course. So please look at this and see log applied to a ratio, not log over log. This is not log of A over log of B. This is log applied to A over B or X over Y. And of course, it goes back and forth. We're going to be using it in both directions. The third rule, and the last one, other than the change of base formula, is the power rule. So log in any base applied to x raised to a power, this number or expression, whatever it is, it goes in front as a factor, meaning it multiplies. It's not addition, subtraction, or anything else, but multiplies log base b of x. So any power inside of, on an expression inside of a log goes in front as a factor, multiplies the log. And before we go back and forth with all these three, let's also get the change of base formula out of the way, which is basically the easiest, I think. So for example, if you ask me log base 3 of 9, what is it? I'll say no problem. I'll change it into an exponential equation, which will be 3 raised to whatever equals 9. And I know the answer. It's not a problem here, right? The answer is definitely 2, and I'm done. However, if you ask me to find log base 3 of 7, initially I may say, yeah, that's okay. 3 raised to which power is 7? But then I can never get this. There is no way. I know for sure it's a number between 1 and 2. Because 3 to the first power is 3, and 3 to the second power is more than 7. So it must be a number between 1 and 3. But how much it is, I have no idea. So some calculators, it's not the calculator that I normally use, has a feature, the new ones have a feature called log base blah, blah, blah. So they allow you to put in the base you want. In this case, we will have log base 3 and of 7. But these are more sophisticated ones, and you may not have a new one. I don't have a, yeah, they gave me a new one. But I don't even know if this one has it. I've never checked.
Is that the 84?
I have no idea. Yeah, plus
yeah, that
C.
has it.
Has
Yeah.
it? Yeah, it does. It has it. I've never used it. I don't care for it. I don't need it. Because the change of base formula is very simple. We still need the change of base formula. Okay? Very simple. How do I determine log base 3 of 7? You understand that this is a unique number. Unique. You will not find one and I'll find a different one. There is no such thing, right? It's 1 to 1. So regardless of which log you want to use, either common log or natural log, you will have log of 7 at the top and log of the previous base in the denominator. Or if you want to use natural log 7 over natural log 3. Do not confuse this with log of 7 over 3. This is log of 7 divided by log applied to 3. Or natural log 7, and this is the change of base formula. So if you go back to the calculator, and you put in log of 7 divided by log of 3, it will give you that answer somewhere between 1 and 2. But now how do I verify this? What if I made an error? Of course, if you determine, if you use it, you have to be consistent. Either common log of a common log or natural log of a natural log. So the number has to be the same if I use natural log, both top and bottom. There's no question there. Because there is only one number I raised 3 to get 7. But how do I check this? I write 3, caret, the power, the previous answer, second, and the minus symbol. When I hit enter, if the answer is correct, what should I get?
7.
Of course. I will not get an approximation. I will get an approximation if I only use 1.77. So 3 power 1.77, I will not get 7. I will be close, but not. But if I recall the previous answer, then I get the exact 7 that I was expecting. So this is a change of base formula. Do you think we should look at a different example with a change of base?
Sure.
Very good. Make one up. Anything you want.
Log of 6.
Base 6.
Base 6. So let's do 17.
Very good. So this is natural log 17 over natural log 6. So natural log 17 divided by natural log 6. I get whatever, 1.58. And then I take 6 to that power. Make sure that I'm getting what?
17.
Good. So the approximate, I didn't write the approximate the first one, and I didn't write the second one. My apologies. So what was the first one? 1.77. Very good. And this one is 1.58. Very good. Is the change of base formula clear? Why do we use log and natural? Because that's what we have in all calculators. Good. So now let's practice the 3 properties, and the product rule, quotient rule, and power rule. So when we are given an expression like problem 21 on page 501, which is log base b of x squared y, we're asked to expand into simple logs. When we're asked to expand, we're basically told, here are 3 properties. Use all of them that are applicable and present an expression with very simple logs. So I have 3 properties available. We do not have a property available that is log of a sum. There is no property for log of a sum. You can't touch that. There is no property for log applied to a difference. You can't touch that. But we can write something for log applied to a product, ratio, or power. So when I look at this problem, first of all, I see a product. So definitely this will change into log base b of x squared plus log base b of y. That's my starting point. This cannot be further simplified. This is done. There is no property that I can apply here, but there is one property that I can apply here. The power rule. So the 2 goes in front as a factor. 2 log base b of x plus log base b of y. We expanded the log applied to, let's say, a complicated expression into simple plain logs. Of course, this was a simple situation. Let's look at the next one. Any questions so far on this? Okay, so I'm going to move on now to 27. If you have your book and you want to choose, please do so. So log base b of x squared y divided by z squared. Okay, we have to try to understand the following. How many factors would you see in the numerator of this expression? How many factors do you see in the denominator of this expression? Perfect. Only the one that comes from the denominator will have minus in front of its log. The ones that come from the numerator will have plus in front of their log. I'm going to repeat this several times. Don't worry about it right now. Okay, first we have to apply the quotient rule. What does it say? It says log of the top in base b, then minus, very good, log base b of z squared, exactly. Exactly what we were expecting. We're expecting that the log that is applied to the quantity from the denominator, we were expecting that that one will have a negative in front. And it does, because it comes from the denominator. Now I see a product. I apply the product rule. Log base b of x squared plus log base b of y. And here I can bring the 2 in front already. Minus 2 log base b of z. There are 2 logs in here that do not need attention. Number 1, number 2, or number 3?
2, 3.
2 and 3. They're done. There is no other property I can apply. But the first one, on the first one I can apply one more property, which is, right, the power rule. Very good. So 2 log base b of x plus log base b of y minus 2 log base b of z. And this is completely expanded. There are no more properties that I can apply here. It's done. It's max expanded. So what did we accomplish? Okay, it's right here. So we had log applied to a complicated expression and we turned it into 3 simple logs. Now the reverse operation is more important than expanding. But I'd like to practice some more expanding and then we'll go condensing. In other words, from this, we're going to be able to come up with that. So we're condensing into 1 log of an expression. But I'd like to work on one more here, at least. Is that okay? Okay, so let's look at a weird one. Like 38, same page. Natural log, x to the 4th, the square root of x squared plus 3, everything divided by x plus 3 to the 5th power. X to the 4th, yes, sorry. How many factors are present in the numerator?
2.
Yes, x to the 4th and the square root. How many factors we have in the denominator? How many will have negative in front of their log? Perfect. Can anyone get us started? Yes, natural log. X to the 4th and the square root. Very good. Yes? Yes. Of x plus 3 to the 5th. Perfect. Next step. Natural log of, yes? Natural log of the square root of x squared plus 3 minus natural log of x plus 3 to the 5th. No more ratios, no more products, but I have powers. What is the power when we see the square root? What power is that?
1/2.
1/2. Very good. So we bring 4 in front. We bring 1/2 in front. And we bring 5 in front. No more powers. You cannot touch this. Please understand there is no property. Do not write natural log x plus natural log 3. That would be a terrible mistake. There's no property for log applied to a sum. Do not touch this. These are untouchable. How do we feel about expanding? Do we need another?
Yes.
Very good. And 26 caught my eye. If you have your book, please choose. 26 log base 8 of 64 divided by the square root of x plus 1. After this, we'll go backwards, meaning condensing. Ready? Good. How do we get this started? Log base 8 of, very good. Exactly. Log base 8 of the square root of x plus 1. Before we continue, let's analyze this. Log base 8 of 64, I have no clue what this is, but I know I can change it into an exponential equation. Exactly. And I have the answer. For this I have. But if you say 3 raised to which power is 7, I don't have the answer. So the answer for this is 2 indeed. So the answer for this is 2 minus, we bring it down the power. What is the power when we see the square root? Very good. 1/2 log base 8 of x plus 1. And this is it. Now we want to go backwards. We want to condense. So let's see how we do the condensing. And the reason I say the condensing is more important is because without understanding how condensing works, we're not going to be able to solve log equations. That's why this is so important. Okay, so let's start with a simple one, like 47. Common log of 2x plus 5 minus log x. Now also you understand that we cannot condense if the bases are not the same. It's not possible. You will not experience that in this class. Yesterday in my pre-calculus class, one of the students, I'm doing the same material with them, but I'm starting trigonometry with them next week. One student asked me, but what happens if I have base 3 and base 4? We have to change the base. Either one into the other or both into base 10. So but not even in that class we need to be as sophisticated. Okay, so what will you say?
So the bases are the same right now.
Of course.
They're 10.
Yes.
2x plus 5 over
Log. Yes.
2x plus 5 over.
Indeed, this is it. So I know it could be confusing. Do not write log of 2x plus 5 over log of x. That would be a mistake. Good. So that was a simple one. Let's look at, let's say, 59. Same page. 3 natural log x minus. I'm copying for 57. Do you want me to, yeah, I'm copying for 57. I'm sorry. 4 natural log of x plus 6 minus 3 natural log x. Since we started with 57, I'll do 57 as well, but let's finish this one because we started it. So yes, whoever invented the whiteout, it was brilliant. Okay, so well, I have a problem here. And the problem is that I can condense only if this is 1. I can condense only if this is 1. But no problem. I know where those numbers come from. This number comes from the power of x. This number comes from the power of x plus 6. That's why it's in front. It's the power rule. Going backwards. So I will rearrange and please tell me what to write. Natural log minus, now I'm ready to condense because the property clearly states 1, 1, 1, 1. So I can condense unless that is 1. So now this will be natural log, 1 natural log applied to a ratio. Because this has negative in front, it has to come from the denominator. This one has plus, it has to come from the numerator. And nothing can be simplified here. Questions? I said 57 because I started to copy it, so 57 was 3 natural log x minus 1/3 natural log y. We can condense before we get rid of those numbers in front. And tell me how to get rid of those. Natural log minus natural log, right, which is the cube root of y. Exactly. Power 1/3 means the cube root. And now I can condense because the coefficients in front are 1. So this is natural log x to the third over the cube root of y. Is that clear? Not too difficult, but there is no other function that has these three properties. Just log. Okay, let's look at one step forward, like 68. I can make them more difficult than this. This is it, really. 5 natural log of x plus 6 minus natural log x minus natural log of x squared minus 25. Now when you look at it, it looks gibberish, but you have already some comfort level already with it, right? You have reached the comfort level with this. So let's look at this expression first. You can't address this yet. That has to be the very last step. These two do not have anything in front. I should say 1. This one has 5, so that has to go. But now how many factors will go to the denominator of the expression? 2. Those that have minus in front. And how many will go to the top? 1, because it has plus in front. Very good. So let's rewrite. It's a lot of writing with this, but it's not. I don't think you find it difficult. So 1/3, I have to eliminate this, which means natural log of x plus 6 to the 5th minus natural log x and minus natural log of x squared minus 25. And now when you're ready, tell me what to write. We already established one factor is coming from the top and 2 from the denominator.
X plus 6.
Exactly. That's it. Of course. Now I want to take care of the number in front. What does that 1/3 mean? The cube root of the whole thing. And we're done. See, initially it looked, but it's really nothing to it. Is this okay? Do you think we need more condensing? We can find another. There's plenty.
For the denominator,
Yes?
is it because the variables is saying that we did it minus them? Or I guess because I'm looking at the quotient rule, or would that not apply to?
You mean why x and x squared minus 25 went here?
Not why they went there, but because now they're, I guess, not the quotient rule, the product rule. Would it add them?
No, there is no addition. Basic. I think I know what you're asking. If you want to use the product rule, you would have to factor out -1 from these two. Change it into natural log x times x squared minus 25, and then have the difference and put that in the denominator. I'm trying to avoid that because you would have to factor out -1. Let me show that. It's a very good question. You don't have to do this. So here's another way. This is what Becca is asking. Okay, so we have negative. That's why from the very beginning I said if it has minus in front, it's coming from the denominator, so you don't have to worry about this. So minus natural log of x squared minus 25. You will have to factor out -1, change it into a sum, then minus natural log of x times x squared minus 25. And then that's how this one ends up in the denominator. But you don't have to do this. It's not wrong. But you don't have to do this because as long as you remember, if the log has minus in front, that quantity has to be, will end up in the denominator, or it's coming from the denominator. Is that what you're asking? Yeah.
And you don't have to bother with the difference of squares at the bottom.
Oh, no, because even if you factor, it's x plus 5 and x minus 5, and you don't have anything at the top to get rid of. You can. It's not a mistake if you rewrite it as x times x minus 5 times x plus 5, but there is nothing you can simplify. So is that better? So you either think in terms of you see two negatives, you factor out, and then you change it into a product, and then you change this, and then you go back to the difference. Or you remember, if it has minus, this quantity ends up in the denominator. If it has minus in front, this quantity ends up in the denominator. Whichever you prefer. Should we look at another condensing?
Sure.
Very good. Yes? Yes, of course. I rely on you to tell me what we need and when we need it. It's a collaboration here.
That minus and this minus.
The reason I put twice, it's not minus minus ever, just to signify that something follows. If I don't write this, then you may say, oh, that's the end. But if I write this and you look for it in the next row, then you know something else is there. But I know not everyone is used to that.
Just do like an arrow.
Yeah, if you want, but I don't want to put an arrow in the middle of an expression, though. But it's up to you. I accept that. So this is a very simple situation as long as you remember that if the log is plus in front, goes or comes from the numerator, the expression will come from the numerator. If it has negative in front, it's coming from the denominator. So this should be just written in one line, one step.
I think I got it.
I know you did. I have no doubt. I'm ready.
All right, log
Yes?
x plus or x times x squared minus 4 over 15 times x plus 2.
That's it. Absolutely. That's all it is to it. But now I do simplify. I do have to factor that because I see a factor that will go away. In the previous example, you could have factored, but it would not have gone away. So this is log x plus 2, x minus 2 over 15 times x plus 2. And we simplify. So log x minus 2 over 15 is fine. So this is like a, if you want, like a foreign language. We learn three properties, we know how to apply them back and forth. That's all it is. But without this, we will not be able to advance in the next section. Any questions? And remember, we have to review this because by Monday, we will not remember, right? So please remember that. Okay. Very good. In the next section, we will finally learn why we are doing what we're doing. So this is why. Our first application of all this. Yes, exponential. We start with exponential, yes. 4.4, exponential equations. Okay, here's the simplest possible equation that I can think of. I'm going to ask you, of course, I know it's redundant and it's a silly question, but I'm going to ask you what type of equation is it? Why?
Because it's written at the top.
Because the variable is the exponent. The variable is found at the exponent. It's nowhere else but the exponent. Very good. Okay, so please do not cross out bases. Do not do anything, just think. Two numbers are equal, and they have the same base. What has to happen to their exponents? They have to be the same. There is no other way. So from here, I know that x plus 2 must equal 3, and I know that x must be 1. Because 2 to the 10th will never equal 2 to the 4th. Only 2 to the 4th will equal 2 to the 4th. So that's why this power has to equal that power. As long as the bases are the same, of course. Yes, of course. I completely agree. As long as, that's what I said, two numbers are equal and they have the same base. Therefore, their exponents have to be the same. And this is the simplest possible exponential equation. Okay, here's the next level. This is a different story. I just made it up. So I don't know what we're going to get. But the left-hand side is 1 over 8 raised to a power. The right-hand side is 32. And what I'm hoping for is to present both 1 over 8 and 32 with the same base. Whatever it is, but the same base. That's my hope. And the answer is yes, it's possible. Because this side can be presented as 2 to the 5th. And this side can be presented as 2 to the... Very good. Awesome. So although I needed an extra step to rearrange the equation, I basically turned it into a simple one. Not yet. One more step, but it's very close. Now the question is, what do we do with these? What operation do we perform when we raise the power to a power? Very good. Excellent. Negative 6x plus 3 to 5x minus 20. We multiply the powers. Very good. An exponential notation raised to an exponent, we copy the base, multiply the exponents. Negative 3 times 2x and negative 3 times negative 1, 5 times x and 5 times negative 4. I'm back to the same simple situation. And here's how I think. Two numbers are equal and they have the same base. What has to happen? Right. So negative 6x plus 3 must equal 5x minus 20. I move 5x because now this is linear and I move 3. So I get negative 11x equals negative 23 or x 23 over 11. Well, this is not always nice. Let's look at another nice one and then look at the ones that are not as nice. Any questions? Okay, here's another nice one. 22 on 514. E raised to x plus 4 equals 1 over e to 2x. This is still a nice one. What is the base on the left? Can I make the right-hand side with the same base? Which base? Which power? That's it. So this is still nice. These two numbers are equal and they have the same base. What has to happen? Right. X plus 4 must equal negative 2x. There is no other way. So if you want to move x, that's fine. So 4 equals negative 3x. And x is negative 4/3. However, moving forward, this will not be possible. So let's say 38. See what happens now. 5 raised to x minus 3 equals 137. Can I make 5 and 137? Can I present them with the same base? Never. It's not going to happen. So before we look at this problem, 2 months ago we looked at this problem. What did we do?
Square.
Why? I want a cube. Why can't I cube? Because the inverse function of the square root is power 2, not power 3. So we use the inverse function. We didn't know that in chapter 2. But then at the end of the chapter 2, we learned inverse functions. So the reason why we eliminated the square root by squaring is because these two are inverses of each other. So keep that idea in mind. I want to apply something like I did here. For this equation, I squared both sides. I want to apply the same procedure or function to both sides that will allow us to bring this power in front. And there is only one function that allows us to do that. The inverse, which is log. Any log you want. Exactly, but the same base. So you want base 10 or you want base e?
10.
Very good. So log and log. Like here, we squared both sides. Here we apply log. It's a different function. Here we squared. It's a function x squared. Here we apply the function log. So I will rewrite the equation just this time. 5 raised to x minus 3 equals log 137. And now this power goes in front as a factor. Please tell me how to write it. It has to be in parentheses. If you don't say parentheses, it will be wrong. Thank you very much. So x minus 3 quantity, log 5 equals log 137. I want to mention one thing. Do not ever get intimidated by this. It's just a poor number. Do not get intimidated by this. It's just a poor number. It's log 5, log 137, just a number. So what do you do next? X minus 3 equals log 137 over log 5. We're dividing both sides by log 5. You do not try to cross log with log. There are different functions. There are different variables, different arguments. This is a number at the top and a number in the denominator. So in order to solve for x, I have one more step to go, which is, of course, add 3. What if my answer is wrong?